Good evening, friends. I am CV Sharma back with another video here. So let's see this question from a tap 10 meters high. Water drops fall at a regular intervals. When the first drop reaches the ground, the fifth drop is out to leave the tap. Find the separation between the second and third drops. Now, there's a scenario here. This is a water tap from which the drops are coming like this. Okay, this is the fifth. Okay, the first drop, this is the first drop which is touching the ground, and it has covered a distance of 10 meters, right? So one can use the equation because by the time it leaves the initial velocity, you can take it as 0. So it drops from rest. Okay. So and then you can see that what time it takes for the first drop to reach the ground. That is half gt square equal to 10. Okay, half g is 10 and t square, that is equal to 10. So you can cancel 10 on either side, and t square happens to be 2. And the time it takes to reach the ground for the first drop is √2 seconds. And now let's move on to the next part of the problem. So here we go. Here is a scenario. Here it is mentioned. So there is a tap, and when the fifth drop is just here, the first drop reaches the ground, and this distance is about 10 meters. And now all the drops, they are coming out at the equal time intervals. Let us say the time interval between each drop is delta t. So this is also delta t, and this is also delta t, and this is also delta t. They are of equal time intervals, and you can see that there are 4 equal time intervals. So 4 delta t, you can say that is equal to the entire time interval for the first drop to reach the ground is √2 seconds, right? So delta t happens to be the time interval √2 divided by 4. So which is nothing but you can write it as 1 by √2 divided by 2 into 2 you can write. So the delta t happens to be 1 by 2 √2. So for the first drop, it is 1 by 2 √2. Let us say for the first drop, let us say t1 is the time for the first drop. So first drop to come out. So that is between the second drop. Okay, I can say that t2 is for the second drop. So for the second drop, it would be like 1 by 2 √2. It takes this much time to come out. And for the third drop, it happens to be 2 by 2 √2. So it's like this. Like this, one can calculate. And now, so like this is the time intervals at which each drops are coming up. Now, so when this first drop reaches the ground, so the crux of the question is when the first drop reaches the ground, what is the separation between the second and third drops? And now let us see this calculation. For the second drop, it is 3 delta t, which has the second drop has traveled a time of 3 times delta t. So 3 times delta t is 1 by 2 √2. So what you get is 3 by 2 √2. This is the time the second drop has traveled. Okay. Now the third drop, if you work out the third drop, how much time it has taken for the third drop to travel, that is again delta t and delta t. So t3 for the third drop is 2 times delta t, where delta t is 1 by 2 √2. And for the second drop, t2 is this is again another delta t here. So that is 3 times delta t. So that is 3 by 2 √2. So taking this into consideration, what is the distance each drop has transferred? So the x2 is the distance the second drop has transferred. So it starts from rest. Each drop will start from rest. So u is equal to 0. So one can use the equation half gt square. So in the case for the second drop, t2 half g t2 square. But t2 is 3 times delta t, so 3 by 2 √2, and For the third drop, you can write half G T3 square, where my T3 happens to be 2 times delta T, that is 2 by 2 root 2. So that these are the numbers you need to plug in here. So x2 minus x3 is the separation here. So x2 minus x3 is the separation here. So what is x2 basically? This entire thing is x2 and this entire thing is x3. Right. So x2 minus x3 gives this separation, that is x2 minus x3. So that is what is depicted here, half G into, this is half G into T2 square, that is 3 by 2 root 2 whole square minus 2 by 2 root 2 whole square. Okay, 2 root 2 whole square is 8. So half G is 10. So 10, 9.8, let us take. So G as 9.8 for the calculation, better calculation purpose. So 9 minus 4 divided by, so you have 8, that's what you have. So half into, so 9.8 becomes 9.8, let us put, and then you have this one is 5 divided by 8 once again. Okay, so this happens to be when I work out that 4.9. So 4.9 into 5. This is what the calculation we have to do. So let me take it like 5 minus 0.1 into 5. So it happens to be 25 minus 0.5. So that is 24.5 for me. 24.5 divided by 8 meters. So 24.5 divided by 8 meters is what I'm getting. So let's see the options, which is closer. So none of these options, but the options, I don't see any option here matching by 24.5 or at least 25 by 8. So the required option is none of these here. So the actual answer here for this problem, it's closer to 25 by 8 meters. So that's the answer for us. And here, none of these is the right option. Yeah, thank you all. Thanks for watching this video, and hope you like this video. Please do like, subscribe, and share. And thank you all once again.